I want to work on some of the problems of the supplement to Chapter 3. I want to show you exactly how to piece these things together so that you have a context on how to use Excel. There's nothing more frustrating to me than grading your papers and seeing you use Excel as a word processor. It truly is one of the most powerful numerical software packages on the market, and you got to learn how to use it, right? In fact, that might be one of the biggest skills I could teach you in this class, even bigger than some of the ideas, is proper use of this program. So I want to go into problem number 4 and let's figure out how to create this network and how to do some of the analysis. We were given the ideas in this table. All of those came to us in the problem set. From that, we were supposed to take the optimistic, most likely, and pessimistic time slots and create an average. So creating an average was given to us in the textbook. It's a weighted average. It's actually a use of what they call the beta distribution. I don't know if I'd worry about the type of distribution. If you're interested, it's in some advanced statistics textbooks. But let's just use what they gave us, right? They said calculate the average as, in the numerator, the optimistic value plus 4 times the most likely value plus the pessimistic value, and then I've closed the parentheses, and then I divide by the sum of the weights. Well, the weights are the numbers in front of each of the numbers in the numerator. So there's a 1 here, a 4 here, a 1 here. 1 plus 4 plus 1 gives me 6. That's how I end up with a 6 down in the denominator. Now, if I can get this equation into Excel correct one time, I should be able to copy this statement all the way down the rest of the table. So I can highlight where I got it right one time. I'm going to move my cursor. See where I've got that gigantic plus sign? It gets a little skinnier, and then it gets skinnier yet when I get to the corner. I can then left click and drag. Or I can even do better. I can get there, and I can double click, and it'll do it for me. So once I have those averages, this column I that I've just created represents the length of time I expect to be at each node in my network. Okay, next step, calculate the variance. The variance was given to us in the textbook. It was from a beta distribution, and the statement says take the quantity of the pessimistic minus the optimistic over 6 and then square it, and then that would be the variance. Now I've added this function round in here. I don't care whether you do that or not. I mean, you eventually might want to, just so that you can make everything look uniform, but there are other ways than using that function to make that happen. But I do want you to start using Excel. So once again, I get this function in here correct once, and I can go to where I have it correct, and I can double click, and I can fill in all of the variances. Now these numbers that I have highlighted represent the average and the variance at each node. Has nothing to do with the network yet. Only the average and variance at the node. Okay. So next thing I'm going to do, once I have this information, I can go and I can construct the network. Now remember how we did this. I think most of you have this ordering down right. I see that right frequently, but you're still hard coding into the network. And I understand. I mean, I understand that it's easier to go that route, but this is a simple network. When you get out and are working somewhere, the networks will get progressively more complex, and you'll be going back time and time again to tweak things to make sure you've got them right. If you don't be careful how you construct these spreadsheets, you'll be reinventing the wheel over and over and over again, which is why I'm trying to teach you to, when you construct the network, there's really 3 things that we can place in here before we start anything. right? I mean, you think, okay, well, each of these nodes has roughly 5 parts. We've got an early start time. We've got an early finish time. We've got a name for the node. Late start, late finish. When we start, the things that we can control before we even make the network are the names of the node, the definition of early finish, and the definition of late start. So we've got 1, 2, 3 things that we can construct before we ever even build the network. So that's why I built a template, so that I don't have to keep reinventing the wheel over and over and over again. So the first thing I do is I have gone in and I've said, well, let me give a name to the network. So I have pointed back to the table at where each letter comes from that's in the network. Why am I doing that? Well, what if I want to call this roofing? Notice that it feeds down into my network. I don't have to change it here and here. I change it in one place, everything is taken care of. Alright, so how do I get these other numbers into the network? Well, the early finish time is equal to the early start time plus the length of time that I'm going to stay in the network. So this reference to E19, well, that's the early start time at this network. And then I'm having Excel go back to the table, find the name of the node, find it in the table, and then it's going out to this average that we created, and that average we created is the length of time that we're going to be at this node. And then I have put that word false in at the end. You don't really need to. You could just close the parenthesis after you put that number 6 in there. 6 is a reference to, I've highlighted the table, and the number I want the function to return back to me is in the 1, 2, 3, 4, 5, 6th column. That's all it's referring to. Now, why do I put the false in there? Because if Excel doesn't find an exact match, I don't want it to go to whatever's closest and default to something. But it's not going to happen to us here. It's not going to. Excel will find the letter A. And the reason we'll find the letter A is because we brought A in from the table. And so, not an issue. Okay? Not an issue. Alright, well, once I had this node down correctly, I then did the cutting and pasting and the connecting of the nodes. I then start in first working from left to right and constructing these early start times. That's where I start. So the early start times, what I do is I go from down the edge and I say, oh, well, what was the early finish time in the node prior to this one? That's going to be my early start time here. As long as there's only one edge coming into the node, that's my definition. If there are multiple edges coming into the node, what I'm looking for is the biggest number. So here, A and C are both feeding into node E. Well, so I take the maximum of the early finish time in node A and the early finish time at node C. And that's the number that belongs here. Now, notice I got that again here. I have 3 edges coming into node G. And so out here at node G, I'm also looking for a maximum. I'm looking for the early finish time from every node that feeds into node G. Okay, so I'm going to work my way through the network constructing the early start times. Then I'm finally going to get this, how long does it take me to get through the node calculated. This is going to be the average value for the entire network. Okay, so now this 20.5 in this example is the mean of the network. Okay, now we can start working from right to left. Well, the late finish time is identical to the early finish time. we're going to get this job done no matter whether we start early or late. It's got to be done the exact same time. Okay? So this node I have to figure out. This node, what I need to do to get the late finish time is just go up and say, well, what's the early finish time? It's the same. Then I work backwards. Now, actually, we've already calculated the late start time, so I don't think we need to go backwards. We should have that one down. But if we haven't figured it out, what it is where I finish minus the length of time I'm at this node. So I'm finishing at 20.5 days, subtracting from that the 4.5 days that I'm going to be in that node. That's what this calculation is. So think of the math of what's going on. Now, the right to left that's the issue is this late finish time. As long as I have just one edge between the two nodes, this late finish time is the same as the late start time that fed it. Same here. Same here. Okay. All those late start times are the same. The only time things change is when I'm going backwards and there's more than a single node going backwards. Then all of a sudden I have to say, okay, well, what's the minimum on the late starts? That's how I get to that minimum. Sorry, that's how I get to that late finish time. Okay. All right, well, enough with this network. The next thing I need to do is figure out, well, what's the critical path? The critical path can be calculated in two ways. And in fact, I think I've even made a video about this before. The critical path is just the difference between the late finish time and the late start time. Or, what would be identical, I could set it up as the difference between the late start time and the early start time. Okay. All we're really trying to do is figure out whether the finish times are different or if the start times are different at each node. So just notice how we go through here. A, D, and G, there is no slack time. But at every other node, there's slack time. Okay? So how do I find the critical path? Well, I find the critical path by looking and saying, okay, well, you don't have to use this formula. It's just convenient, that's all. And I'm all for convenience. So what I've done is I've said, go looking in cell G22. If it's equal to 0, then just put an A in this cell. Otherwise, make it empty. That's what the double quotes say to do. Okay? So I copy that. Once I've got it right, I copy it. And it goes looking and says, oh, well, that A, D, and G are the critical paths here. All right, now to the things that are different. Now I need an average, not for each node. Did that. What I need is an average for the network. Well, the average for the network is the length of time that we're going to spend in the network. So I go to the early finish time or the late finish time in the very last node. I get the number from there as my average for the network. Now for the variance, what I need for the variance is I need the nodes that are on the critical paths. So I know A, D, and G are on the critical path. The variance for the network is the sum of the variance at just those nodes on the critical path. Okay? And then the standard deviation is taking the square root of the variance, just like it's always been. Okay? Finally, questions about probability. We are using a normal distribution. This problem says I need to find some value of time so that I am 90% sure that I'll be done. So I use this norm.inv, norm inverse. It takes a probability, in this case 0.9, and then the mean and the standard deviation, and it returns a value for t. This one says a time of 22.8 days, months, whatever the units are, and I'm 90% sure that I'll be done. So look, it says I expect to be done in 20.5 days. That really is just a 50% probability because we're working with a normal distribution. The probability of the normal distribution and less is 50%. Well, I'm beyond 50%. So this one says I've got to go an extra almost day and a half, 2 days. Yeah, I guess almost 2.5 days above or beyond to be 90% sure I'm done. So anyway, I'm going to stop this for now because it's getting long. But I want you to start thinking about what you're doing when you're doing the math. But I also want you to start using Excel as a tool because it is going to be your tool of choice in a business setting. All right, thank you.